Hello students, welcome to Anne's classes. Let's do chapter 1, Rational and Irrational Numbers, exercise 1A. Exercise 1A, page 5. Question 4. Arrange 5 by 8, negative 3 by 16, negative 1 by 4 and 17 by 32 in the descending order of their magnitudes. That's the first thing that we need to do. We have to arrange these rational numbers in descending order. Then find the sum of the lowest and the largest of these rational numbers. So pick out the lowest and the largest, find the sum, add them up. Then express the result obtained as a decimal fraction correct to two decimal places. So there are three parts to this question. The first part is arranging in descending order. So we have the question here now. We have to find the LCM of the denominators. Now let's do that. So the numbers, the denominators are 8, 16, 4 and 32. So let's find the LCM of the denominators. 2 4s are 8, 2 8s are 16, 2 2s are 4, 2 into 16 is 32. We continue again with 2, 2 2s are 4, 2 4s are 8, 2 1 and 2 8s are 16. We'll continue with 2 again, 1, 2 2s are 4, then 2 4s are 8, 2 again, 1, 1, 1 and 2 2s are 4. Now we continue with 2, 1, and it's all 1. Now let's find the LCM. LCM is equal to all the 2's. Now how many 2's are there? There are 5. So 2 into 2 into 2 into 2 into 2. 2 2's are 4. 4 2's are 8. 8 2's are 16. 16 2's are 32. So 32 is the LCM. So we're going to use the LCM as a common denominator. So in this case, the denominators are all 32. So for the first fraction 32, second one 32, third one 32 and the last one also 32. Now we're going to find the numerators. So look at the denominator 8. 8 4s are 32. So we multiply 5 into 4. 5 times 4 is 20. 5 4s are 20. Second fraction 16 times 2. 16 into 2. So negative 3 into 2 is 3 2s are 6. So negative 6. Next one 4. 4 times 8 is 32. So we multiply 1 by 8. 1 8s are 8 and that's negative 8. Next we have 32 itself. 32 into 1. So 17 into 1 will give us the same number, that is 17. Now let's arrange the numbers in descending order. Descending is from big to small. So since we have negative and positive numbers, we're going to put the positive numbers first because they are greater than the negative ones. And the positive numbers are 20 by 32 and 17 by 32. The bigger one is 20 by 32. So we write that first. So that is 20 by 32 is bigger than the other one, that is the other positive number 17 by 32. Now we look at the negative numbers. We have negative 6 and negative 8. Which is the bigger one? Negative 6 is bigger than negative 8. So we write negative 6 by 32 is greater than negative 8 by 32. Now we have to go back to the question and arrange these in order based on the answers that we got. 20 by 32 is 5 by 8, which is given to us in the question. So we write 5 by 8 is greater than, now 17 by 32 is the last one, that is 17 by 32 itself. 17 by 32 and this is greater than negative 6 by 32. So negative 6 is here, that means negative 3 by 16. Negative, let's write that, negative 3 over 16 is greater than the last one. So here we've written 5 over 8, we wrote negative 3 over 16, we wrote 17 by 32. What is left is negative 1 by 4. Negative 1 by 4. So this is the descending order of the rational numbers given to us in the question. Now the next thing is we have to find the sum of the lowest and the largest of these rational numbers. So to find the sum of the lowest and the largest. Now here we have the largest 5 by 8. Here we have the smallest. So we have to find the sum of 5 by 8 and negative 1 by 4. So we have to find this, the sum. Since it's addition and since they're fractions here, rational numbers, now we have to find the LCM of the denominators. One is 8, one is 4. So it's understood that the other one will be, that the LCM will be 8. So this is 8 plus here also we have 8. So here let's look at the first one. 8 ones are 8. So we multiply 5 also by 1. We get the same thing, that is 5 by 8 plus here we have 4 into 2. So negative 1 into 2 is negative 2. So this is 5 plus negative 2. The denominator is 8. Now this is plus, isn't it? Now this is addition. Signs are different. We put the sign of the bigger number and we subtract. So subtraction, sign of the bigger number is plus. Subtraction 5 minus 2 is 3. 3 by 8. So this is the answer, plus 3 by 8, or we simply say 3 by 8. Now the third part of the question says express the result obtained. That means this is the result that we got. We have to express this as a decimal fraction. Now it's in the form of a regular fraction. We have to write it in the form of a decimal fraction correct to 2 decimal places. That is 3 by 8 to 2 decimal places. How much will that be? We have to divide 3 by 8 and see. So let's do that. 3 is smallest. We begin with a 0, put a point, put a 0, 30. 8 threes are 24. We need to get a number close to it. 30 minus 24 is 6. Now we need to continue because we have to get 2 decimal places. So whenever we have to get 2 decimal places, we'll take one extra place and then round it off. Okay, so that means we're going to get 3 decimal places here. Now we have 6 here. I'm going to put a 0 and bring that 0 down. Now 8 and 68 sevens are 56. A number close to that, minus, now 60 minus 56 is 4. I'm going to put a 0, bring that 0 down. Now the number is 40 and this will go. 8 fives are 40 minus 0. So what do we have in our quotient? 0.375. Let's write that. 0.375. Now we have to round it off to only 2 decimal places. So when we do that, we have to look at the third place. If it's 5 or more than 5, this will change. That means this is going to become 0.38. So this is our answer, 0.38. So 3 by 8, this is the result that we got here, isn't it? Now this expressed as a decimal fraction correct to 2 decimal places will be 0.38. The answer that we got. So we have expressed this also as a decimal fraction correct to 2 decimal places. Question 5. Without doing any actual division, find which of the following rational numbers have terminating decimal representation. So we have 5 questions here. Now we need to find if any of these rational numbers have terminating decimal representation. That means if we divide the numerator by the denominator, will the decimal, that is the quotient, terminate? Will it be a terminating decimal? And we have to do this without doing any actual division. So we are not going to divide 7 by 16 or 23 by 125 and so on. Without doing actual division, we have to find out. Now, how can we do that? We can do it this way. That is, if the denominator of the rational number can be expressed in this form, that is 2 to the power of m into 5 to the power of n, where m and n are whole numbers. Both should be whole numbers. Then you can say the rational number is a terminating decimal. It can be converted to a terminating decimal. We should be able to express it in this form. So let's take the first question to make it easier for us to understand. So the first question is 7 by 16. Now we are not going to do actual division. Instead, we're going to take the denominator and find the prime factors. So denominator is 16. Let's find the prime factors of 16. Take 2. 2 8s are 16. Then 2 4s are 8. Continue. 2 2s are 4 and 2 1s are 2. So this is 2 to the power of 4. That means 16. The factors of 16 are the prime factors 2 into 2 into 2 into 2, which is equal to 2 to the power of 4. Now, can we express this in the form of 2 to the power of m. So we got 2 to the power of 4 into 5 to the power of n. Can we express it in this form? We can do it. Now how can we do it? So this is in the form of 2 to the power of m, which is 2 to the power of 4, into, we can say, 5 to the power of n, and in the place of n we can put a 0. Now, how much is 5 to the power of 0? 1. 2 to the power of 4 is 16, we found out. So 16 into 1 is 16. That means we can express 16 in this form, that is the form 2 to the power of m into 5 to the power of n. Now, since we don't have any other number here, we can write 5 to the power of 0 because this is equal to 1. That means 16 can be expressed in this form, isn't it? Now, since 16 can be expressed in this form, we can say that 16 has a terminating decimal. So 16 is a 7 by 16. This whole rational number is a terminating decimal. I hope you understood the steps. So we have the question here. Take only the denominator. Find all the prime factors. Now, if you can express the prime factors in this form, that is the form of 2 to the power of m into 5 to the power of n, then you can say that that rational number is a terminating decimal. Let's go to the next question. So next question is 23 by 125. So let's take only the denominator and find the prime factors of the denominator. So let's begin with 5. 5 2s are 10. So we have 2 left here, 25. 5 5s are 25. Then we have 5 into 5, 25, continue. 5 1s are 5. So this is 5 to the power of 3. So the denominator 125, the prime factors are 5 into 5 into 5, which is 5 to the power of 3. Can we express this in the form of 2 to the power of m into 5 to the power of n? Now 5 to the power of n we already got, isn't it? That is, we've got 5 to the power of 3. Now 2 to the power of n, since we don't have any other number, we can include 2 there and write 2 to the power of 0. Because 2 to the power of 0 is equal to 1. So here what can we write? We can say 2 to the power of 0, that is 1, into 5 to the power of 3, which is 125. So 1 into 125 is 125. That means we can express 125 in the form of 2 to the power of m into 5 to the power of n. So it can be expressed in that form. That means this rational number 23 by 125 is a terminating decimal. So what should we do? Take the denominator, find the prime factors, see if you can express it in this form. Since there's no other number with 5, we can add 2 to the power of 0 because that will be equal to 1. 1 into 5 to the power of 3. Question 3. Now here we have 9 by 14. Let's take the denominator 14 and find the prime factors of 14. So begin with 2. 2 sevens are 14. So now we go to 7. 7 ones are 7. So 14 is 2 into 7. Now can this be expressed in the form of 2 to the power of m into 5 to the power of n? We can't do that because 2 to the power of m, we have 2 to the power of 1, we can say. But this number is 7, it's not 5, and we can't put 5 here because 7 is there. If there's any other digit, then you must remember you cannot express it in this form, 2 to the power of m into 5 to the power of n. So let's write that. So 14 cannot be expressed as 2 to the power of m into 5 to the power of n. That means this rational number 9 by 14 is not a terminating decimal. Question 4. Here the denominator is 45. Let's find the prime factors of 45. Let's do that. 45. Let's begin with 5. 5 nines are 45. Now 3 threes are 9, 3 ones are 3. So for 45, what are the prime factors? 3 to the power of 2 into 5 to the power of 1. Now, are we able to express this in the form of 2 to the power of m into 5 to the power of n? We cannot, because in the place of 2, we have another number 3. If you have any other number other than 2 and 5, then you cannot consider this to be a terminating decimal. So that means this cannot be expressed in this form. So let's write that 45 cannot be expressed as 2 to the power of m into 5 to the power of n. That means this rational number, that is 32 by 45, is not a terminating decimal. Question 5. 50 is the denominator. The rational number is 43 by 50. Let's find the prime factors of the denominator 50. So 50, begin with 2, 2 into 25, and now let's continue with 5. 5 fives are 25, 5 ones are 5. So the prime factors of 50 are 2 into 5 into 5. We can write this as 2 to the power of 1 into 5 to the power of 2. Are we able to express this in the form of 2 to the power of m into 5 to the power of n? Yes, we have 2 raised to the power of 1, 5 raised to the power of 2. Remember, you have to raise it to any whole number. The power should be any whole number. It can also be 0. So that means 50 can be expressed as 2 to the power of m into 5 to the power of n. And that means this rational number 43 by 50 is a terminating decimal. We'll stop with that for now, children. In our next video, we will continue with the remaining questions. Thank you, children.